Welcome back to another Biostatistics video. This time we'll be talking about statistical distribution. So we'll be covering measures of central tendency, measures of dispersion, and the normal distribution. And since we're going to be talking about the normal distribution, we also have to talk about the non-normal distributions. Okay, so let's start with measures of central tendency. There's mainly three topics: mean, median, and mode. And these are just like what you learned back in high school. So mean is basically the sum of all the values and then divided by the total number of values. For example, if you have 1, 2, and 3, you add them all together. So 1 plus 2 is 3, 3 plus 3 is 6, 6 over the number of terms. We have 1, 2, and 3. So over 3, and you get 2. So the average is 2. The average of this set of values is 2. The mean of those set of values is 2. Now, since the mean actually cares what this number will eventually be, and since this number is made up by the addition of these numbers, then if we have an absolute extreme number, like for example 1 million, so on, then this number, it'll be so high that it's going to basically push this number all the way to maybe like 500,000 or something. So the idea generally is that as you have outliers means extreme values, you're going to have the mean become really affected. When we talk about median is actually just the middle value. So it cares about position. So let's say again we have, for example, 1, 2, and 3. We would knock out 1, knock out 3, and then you got 2 right there in the middle. This is how you want to do it. Now they might trick you. What they might do is they might give you 2, 3, 1. What you need to do is you need to first organize the numbers. So put them from 1, 2, and 3, and then you need to cross them out. So you put them back in 1, 2, 3. You cross this number, and you're gonna get 2. If you ever get stuck between two numbers, just take their average. For example, if we have 1, 2, 3, and 4, you cross out 1, you cross out 4, or now you're stuck between two numbers, so that the median is going to be 2.5. Right in the middle between these two numbers, the average of these two numbers. 2 plus 3 is 5, 5 over 2 is 2.5. It's less affected by outliers because if we had, 1 million back here, 1 million, just pretend that this is 1 million, it's going to get crossed out. So basically the median will still stay very close because it cares about position, not really about the value itself, unlike mean where it cares about the value itself. This is why it's preferred over the mean when we're talking about statistics with outliers. When we talk about mode, it's the most common value. So for example, if we have 1, 1, 1, 2, and 3, then the mode here is 1 since it's repeated 3 times. So whatever is repeated the most amount of times, then basically that's going to be our mode. And as it mentions, it is the least affected by outliers because no matter what amount of numbers are here, unless they're being also repeated, those exact numbers, and they're being repeated more than these numbers, the mode will never change. The mode will still remain 1 since here is being repeated 3 times. If we add 1,000, if we add whatever numbers after it, it'll still be 1. So let me just clear the board real quick. Next up, we have measures of dispersion. So we talked about, if we have a distribution, what we talked about right now is how can we understand where the center of this curve is, and the three ways we can do that is with mean, median, and mode. This is how we tell the center of it, measures of central tendency. But how do we know how dispersed it is? Curves can be, for example, very narrow like this, or they can be very dispersed like this. So if they both have, for example, let's say the same center, then how can we know if it's narrow or if it's wide? Well, we have certain measures of dispersion for that. We have standard deviation, we have standard error. Now, they're not interchangeable. Usually, you either have this one or this one. So let's start with the first one, standard deviation. Standard deviation dictates basically how much you're moving, either positively or negatively, from the mean. For example, let's say the standard deviation was 6. Let's say the standard deviation, let's say sigma. It's called standard deviation. Let's say it equals 6. If we have a distribution, and let's say right here is 0, then one standard deviation will send us 6 points this way, and our first standard deviation will be 6. Then if we go another standard deviation, which is going to be 2 standard deviations, it's going to be 12, and so on and so forth. And you can do negative standard deviations. For example, minus 1 standard deviation, it's going to be negative 6, and then another negative standard deviation is going to be negative 12. So the idea of standard deviation is if you're going one standard deviation to the right or the left, you're going that many points. So what standard deviation does actually, it just pretty much shows us the variability of all these points. Like for example, maybe there are more points here in the middle. That's why it's getting really big around the center. But there are less points down here. So it's showing us the variability of these sets of values. What they figured out is that if we take let's say 3 of these values and then make a mean and then plot that mean and then take another 3 values, plot that mean, take another 3 values, plot that mean, we'll actually get a much narrower curve, and they call that standard error. So the best way to highlight that is that as you increase the sample size, it's just going to be standard deviation, this little sigma, divided by radical n. So when you set it like this, as you keep increasing n, your standard error will go down. As you keep increasing this number, since it's in the denominator, this number will go down, and vice versa. If n goes down, the standard error will go up. It's very important to realize whether they're asking you for standard deviation or for standard error. Sometimes maybe they asked you for standard deviation, but you're too busy, doing divided by radical n, that you get a wrong answer, and that's not what they want. They want standard deviation, and maybe vice versa. Maybe they're asking for standard error, and you forget to do divided by radical n, and you're doing standard deviation, and you get the wrong answer. So always be careful. Are they asking for standard deviation, or are they asking for standard error? It's always a common mistake I see some of my colleagues do. So let's talk about the normal distribution. This is the normal distribution that I was drawing here. Now it's not perfectly symmetrical, not like this diagram right here. And then as I was saying, notice how here it's -1 standard deviation. Here it's +1 standard deviation. And if you check everything that's between these two marks, you're gonna have 68% of the data. And if you go 2 and 2, both right and left, you're going to have 95%. And if you go 3 and 3, you'll have 99% of the data encompassed within these between these 2 points. In the normal distribution, since it's also very symmetric, any, for example, outlier here is equally matched by an outlier here. So in general, you're going to have the mean and median and mode exactly the same, because this is perfectly symmetrical, so all of them should land right in the center. Mean, median, and mode should land all in the center. However, what if it's not normal? In other words, what if it looks just weird, if it doesn't look symmetric? In this case, it does look symmetric, but what's weird about it is that it has 2 humps. It has two very common values. So in this case, for example, it shows that there's one major population in this peak and another major population in this peak, and they give you slow acetylators, fast acetylators, and the age of onset of Hodgkin's lymphoma, for example. Sometimes it could be young versus old. People in between generally do not get Hodgkin's lymphoma. So the general idea is that you have 2 main populations. That's why they're causing two sort of peaks. When it's positively skewed, that means what you're doing is you're adding points here. You're adding a sort of like outliers. You're adding them all over here. So what it's doing is it's slanting, it's sort of pulling the graph all the way to the right. It's pulling this tail all the way to the right. It's positively skewing it. It's going all the way to the positive side. So what happens is the mean gets pulled. The mean gets pulled the most because, again, it's actually getting affected most by these values. Since the mean, we talked about it gets affected by the values. The median is also getting slightly pushed since the position is changing. If we're adding points here, the position is slightly going to the right, but less so than the mean. And mode, it's the least affected by outliers. It'll stay at the peak right here. And when it's negatively skewed, you can see we're adding points this way, so they're all going negatively. They're all going negatively, and this tail is being pushed, or pulled rather, to the negative side. And you can see that the mean, median, mode is basically flipped. The mean starts first here, and then median, and then mode. With that said, I hope you enjoyed this short video. Consider liking and subscribing, and as always, thanks for watching.